Everyone, we're going to take some class notes. I want to review 11.2 and 11.3 together before we move on to 11.4. So just so that you can remember all of what we've accomplished in these two sections. We're solving and graphing both exponential and logs. And so it's a worksheet that I've created. I'm going to work 2, 4, 8, and 10, and then you're going to work the rest of them for homework. So I have those 4 on this paper. I'm going to go ahead and start. The first one says to solve the equation is what the direction says. Well, you have to recognize what type of equation is it. This is an exponential equation. And so what we've learned on how to solve exponential is to write these with the same base, and the property says the exponents we can set equal. So if this is base 6, on my base sheet, I'm going to go to base 6, and I see 6, base 6, 6, and 36. So I'm going to rewrite 36 as 6 squared. So I'm keeping this side 6 to the negative 3n, and this side I'm rewriting as 6 squared. Now, because we have the bases the same, we can use what that property says. Forget about the bases, set the exponents equal, and solve. So I get n equals negative 2/3. And you can always check by plugging that back into the original. When I look at 4 is also in the section of solving, but it's clear to me that this is not an exponential equation. This is a log equation. So what we just did yesterday in notes is solving log. We said let's switch forms because that's what we're more familiar with. We're more familiar with solving these types of equations. So switch to exponential form and then see where your variable is and how you need to solve that. So this is the base, this is the value, this is the exponent. Exponentials are written with base to a power, exponent, equals a value. And so I can see that the k's alone, and then I just need to solve this linear. This is a linear equation, it's not an exponential. I switched forms from log to exponential, but this is not an exponential equation because this is not a letter. Therefore, I can see that this is linear. All I have to do is take 12 to the 0. Anything to the 0 is 1, and I am done with number 4. Solving a log, or graphing, in 8, it says to graph and find domain and range, so we can talk about that as well. I have to switch forms, but I like this one because you don't see the base, and so it's like a square root. When we don't see the square root, we know that the index is 2. With logs, when we don't see the base, we have to know that the most common log base is 10. So if it's not there, you need to write in a 10. So switching forms, base, exponent equals a value. And so I probably would still make a table, and I'd probably still pick my y values, but I'd also subtract over the 6 at the same time. So I'm going to write this as 10 to the y minus 6 equals x. So that once I pick what my x is, I can just subtract the 6 from there. And so I think I'm going to just use for y, I don't know, I guess I'll use -1, but I think I want to keep them positive because I don't want to have to deal with subtracting 6 and dealing with fractions. So I'm going to go -1, 0, 1, and 2. When I plug in a -1, I get 1 over 10. So 1 over 10 minus 6 over 1. That needs to be multiplied by 10, 60 over 10. So I'm going to get -59 over 10. When I plug in a 0, 10 to the 0 minus 6 is going to give me my x. Anything to the 0 is 1. 1 minus 6 is going to be a -5. When I plug in a 1, 10 to the first minus 6 equals x. That's going to be 10 minus 6, which is 4. And then when I plug in 2, I'm going to get 10 squared, which is 100, minus 6. And 100 minus 6 is going to be 94. And so 94 and then 2. Okay, so my y's I'm going to count by ones. On my x's, on my x-axis, I'm going to go ahead and count by maybe 10s because I got to graph that 90, 10, 20, 30, 40. Okay, so I have to move over And then you can find out what this is approximately, but I have to move over -1, 2, 3, 4, 5, and then down 1. 1, 2, 3, 4, 5, past 5, closer to 6, closer to -6 is what I should say. Then I have to move over 5 and stay at 0. 5 to the left, stay at 0. 4 to the right. And oh, I'm counting by tens though. Okay, hold on one sec. Let me start over. I apologize. I should probably go -10, -20. And so -6, down 1, -5, stay at 0, 4, up 1, and 94, up 2. So here is what my graph is going to look like. These are what our log functions look like, approaching that there. So that piece, it's approaching but not touching. So it starts, that's the domain, right? Domain starts at the -59/10, but doesn't touch there, although that is a point. So it's going to probably be directly at, I'm just going to go ahead and leave it that way for now. And then it goes to infinity. And the range, I see this graph going down and I see this graph going up. So my range is going to be -infinity to +infinity. In graphing 10, well, I see that this is exponential. So now this time I'm going to pick my x values. And I'll pick -2, -1, 0, 1, and 2. And I get y equals 4 to the -2, which we know is 1 over 4 squared, which is 1/16. Plugging in a -1, 4 to the -1 is going to be 1/4. Plugging in 0, 4 to the 0 is going to be a 1. 4 to the first is going to be 4, and 4 squared will be 16. So this time I'm going to make sure, and this is how we graphed the first time with exponentials, we counted by ones on our x, and I'm going to count by, let's go twos. 2, 4, 6, 8, -2, -4, -6, so I don't forget that. All right, so moving 2 to the left and then up a 16th. 1 to the left and up a 4th. 0 up 1. 1 up 4 and 2 up 16. 8, 10, 12, 14, 16. And so here I can see that this is an exponential growth. It's growing very quickly, approaching. We have a horizontal asymptote here. With log, we have a vertical asymptote. Growing, it's increasing but slowly. This one is increasing but quickly. Okay. 10 does not ask for domain and range. Don't worry too much about domain and range, but challenge yourself and try. Bye everyone.